Want to go to space? Get a rocket. Nothing else ever invented can release the tremendous amount of energy in a controlled way to get you to orbit. It all comes down to velocity. So right now, you're standing still on the Earth, and if you jump up, you'll come right back down where you started. But if you had a sideways velocity of 10 meters per second and you jumped up, you'd land downrange a few meters, painfully. And if you were moving 7,800 meters per second sideways and you were a few hundred kilometers up, you'd just orbit the Earth. Gaining that kind of velocity takes rockets. Those magical science thunder tubes are incredibly expensive, inefficient, and single use. Imagine if you had to buy a new car for each commute. Just blasting a single kilogram to orbit typically costs about $10,000. When you buy a trip to space, only a few hundred K goes into the gas. Those millions of dollars mostly go into the cost of the rocket that you're going to kick to the curb once you're done with it. SpaceX is one of the most innovative rocket companies out there. They figured out ways to reuse as much of the rocket as they can, slashing those pesky launch costs, which ruin what should otherwise be a routine trip to the moon. Maybe in the future, rockets could be used hundreds or even thousands of times, like your car or commercial airlines. Is that the best we could do? Can't we just ditch the rockets altogether? To get from the ground to orbit, you need to gain 7,800 meters per second of velocity. A rocket gives you that velocity through constant acceleration. But could you deliver that kind of velocity in a single kick? How about a huge gun and just shoot things into orbit? You need to instantly impart enormous velocity to the vehicle. This creates thousands of times the force of gravity, G's, on the passengers. Anyone on board gets turned into a fine red coating distributed evenly throughout the cabin interior. You can only get away with this a few times before your guinea pig passengers get wise. Steward, there's bone chips in my champagne. If you extend the length of the barrel of the gun over many kilometers, you can smooth out the force of acceleration that humans can actually withstand. So this is the idea that StarTram proposed. They're looking to build a track up the side of a mountain and then use electromagnetism to push a sled up to orbital velocity. This might sound far-fetched, but many countries are using maglev technology with trains and breaking speed records around the world. The Japanese recently pushed a maglev train to 603 kilometers per hour. So this first version of StarTram would cost $20 billion. And the tremendous forces would only work for any cargo being delivered in a non-living state, despite how it started out. Even more expensive is the version with a 1,500 kilometer track, able to spread the acceleration over a longer period and allow humans to fly into space, arriving safely in their original non-pace configuration. There are a couple teeny technical hurdles, such as a track 20 kilometers in altitude where the projectiles exit the muzzle, and venting the atmosphere to prevent the shock wave that would tear the whole structure apart. But if it can be made to work, we could decrease launch costs down to $50 a kilogram, meaning a trip to the International Space Station could cost $5,000. Another idea would be, unsurprisingly, lasers. Now, I know it sounds like I'm making this up. Lasers can fix every future problem. They could track and blast launch vehicles with a special coating that vaporizes into gas when it's heated. This would generate thrust like a rocket, but the vehicle would have to carry a fraction of the mass of traditional fuel. You don't even need to hit the rocket itself to create thrust. A laser could superheat air right behind the launch vehicle to create a tiny shock wave and generate thrust. This technology has been demonstrated with the Lightcraft prototype. What about balloons? It's possible to launch balloons now that could get to such a high altitude they're above 90% of the Earth's atmosphere. This significantly reduces the amount of atmospheric drag that rockets would need to complete the journey to space. The space colonization pioneer Jared K. O'Neill envisioned a balloon-based spaceport floating at the edge of space. Astronauts would depart from the spaceport and require less thrust to reach orbit. We've also talked about the idea of a space elevator, stretching a cable from the Earth up to geostationary orbit and carry payloads up that way. There are enormous hurdles to developing technology like that. There might not even be materials strong enough in the universe to support the forces. But a complete space elevator might not be necessary. It could be possible to use tethers rotating at the edge of space, which transfer momentum to spacecraft, raising them step by step to a higher velocity and eventually into orbit. These tethers lose velocity with each assist, but they could have some other propulsion system like an ion drive to restore their orbital velocity. Future methods of accessing space will be a combination of some or all these ideas together with traditional and reusable rockets, balloons and air launch systems to decrease the rocket's drag, electromagnetic acceleration to reduce the amount of fuel needed, and ground-based lasers to provide power, additional thrust, and pew-pew noises. Perhaps with a series of tethers carrying payloads into higher and higher orbits. It's nice to know that engineers are working on new and better ways to access space. Rockets have made space exploration possible, but there are a range of technologies that we can use to bring down the launch costs and open up whole new vistas of space exploration, colonization. I can't wait to see what happens next. So, what alternative methods of getting to space are you most excited about? Let us know your thoughts in the comments below. Don't forget to stick around for the blooper. Thanks for watching. Click subscribe or like it on Facebook. Never miss an episode. If you'd like to learn more about the exploration of space, check out our spaceflight playlist. Thanks to Peter Soja, Tyler Johnson, Nigel Olton, and the members of the Guide to Space community who keep these shows rolling. Love space science? Want to see episodes before anyone else? Get extras, contests, and shenanigans with Jay, myself, the rest of the team. Get on the action. Click here. You ready?
How's the top of his head? It's getting pretty close. Yeah. Is he getting taller?
I wish.
Stand up straight. Good. Okay. I was worried on the first one, but I was watching it.